All right, folks, reviewing our last lab here from chapter 14. Wanted you to do 6A and B, and for B, I also wanted you to report the coefficient of determination. And then question 10, parts A, B, and C. So I've already thrown up the answer for 6A here, just so you didn't have to watch me draw it. So you should have drawn something that looks pretty similar to that. Now, one of the things that is talked about in the book that I ordinarily would be talking about quite a bit if we were doing this live is using these to estimate the math value. So all we're really saying in this case under these circumstances is that the rounder the envelope is, the more the envelope looks like the number 0, the more the math answer should be close to a 0. The skinnier that envelope gets, the more it looks like a flat line, the more it would look like be the number 1. So it's something that students struggle with anyway. I mean, a 0 and a 1 are pretty easy to predict when you see them, they're extreme. But when you're looking at this, trying to predict a number from that without experience, particularly for us being able to do this together, is tough to do. So the most important thing to predict really for us is simply, is it positive or negative in its direction? Don't worry about so much trying to predict the number. I wouldn't ask you to predict a number on a quiz or an exam anyway. So we can see this is negative. It's a pretty skinny envelope. This is probably in the 80s somewhere. I think your book mentions that if it's roughly football shaped, which is about a 3-to-2 ratio, then that's put you in the neighborhood of about a 0.70. This is certainly flatter than a football, so skinnier, more like a 1. But anyway, that's all we needed to do on that. See that, get a sense that it's a pretty precise one, so the number will be up a little bit, and that it is a negative. So that's what we wanted for 6A. 6B, just doing all 4 steps of the hypothesis test for our Pearson R. So in doing your prep work, you should see that the summation of x was 25, summation of y is 15, summation of squared x's was 131, summation of squared y's was 69, and summation of products, x times y, was 65. So that was your scratch work stuff. So step 1, stating our hypotheses. The alternate hypothesis is the rho, the population rho technically, that rho will not equal 0 because we're doing a two-tailed test. And the alternate the null says that rho will equal 0. Alternate says rho not equal 0. Now when you're typing this, again, if you can find a rho symbol in Canvas, great. Otherwise, RHO is how we're going to spell the word rho. Step 2, which we are using an alpha level of 0.01. We have 3 degrees of freedom in this two-tailed test. So our critical R is plus or minus 0.959, right? Think about how close to perfection that is. Why are we demanding so close to perfection? Because we only have 3 degrees of freedom. There's only 5 people in this study. If I'm going to conclude a pattern exists based on measuring 5 people, that better be the most rock solid pattern you've got, right? So it better be darn near perfect based on 5 people. If we had a bigger sample size, larger degrees of freedom, we would find that critical value starts to drop. We can get a little less rigorous about it. Anyway, plus or minus 0.959. Your summation of squares for the x variable was 6. Your summation of squares for the y variable was 24. Your sums of products was negative 10. And so your R value was negative 0.83, rounded off, right? Negative 0.83. So we look at our critical of plus or minus 0.959, and we miss the shaded area, so our decision is to fail to reject the null, concluding that we don't have enough solid enough proof or reliable enough evidence to say it looks like this pattern is legit. So we failed to reject the null. If we were writing that in APA, we would say an R equals negative 0.83, semicolon, N equals 5, semicolon, P greater than 0.01. Now, the coefficient of determination, take your 0.83 and square it, your negative 0.83. But remember, calculate with the full thing. So it's negative 0.83333333333333. Square that. When you do, you'll get 0.6944444, not done out to a 3. So your coefficient of determination is 0.69. R squared equals 0.69. So if I knew variable x, I could predict variable y with about 69% accuracy. Not too bad. So that is our question 6b with our coefficient of determination. And then lastly, question 10, parts A, B, and C. 10, for a two-tailed test with an alpha level of 0.05, use our table to determine how large a Pearson correlation is necessary to be statistically significant for each of the following samples. It's a really weird, unusual wording for us, but it's just saying go get the critical R values. That's all it's saying. Again, how large a Pearson correlation is necessary to be significant. That's what our critical value is. So A, we have an N of 6, which means we have 4 degrees of freedom. Well, if the alpha level is 0.05 and it's a two-tailed test with 4 degrees of freedom, our critical R would be plus or minus 0.811. B says a sample size of 12, so that's 12, 11, 10 degrees of freedom. Two tails 0.05 with 10 degrees of freedom. Our critical R is plus or minus 0.576. And then lastly, with the largest sample size of 24, we can see our critical goes down to plus or minus 0.404. So those are the answers to our final statistics lab in this course. As always, one more time, questions, concerns, problems, just want to say hi, send me a line through Canvas or through email. But this wraps up what should be our last video for this course. All right, everybody, take care.